So thank you for staying over here. I'm going to keep it short and rapid. So it's just to present to you some tools for metabolite ID and inhibition studies that we are about to launch in the next few weeks or month. So one thing that you should be looking for those who are using the 5000, we are coming up with a new version of LightSight, software version 2.2, and it's going to be optimized really for take advantage of a few of the things that are actually available in the 5500 Q-Trap system. So what are those features? Integrated support for the Acuity UPLC system. We realize that it's one of the most widely used systems out there. So we are supporting this through method building as well as processing the data. We're allowing people also to save custom sets for processing parameters. So we're making run large scales experiments easier and quicker to build within the LightSight program. We also now support processing non-MS analog data, so UV and radioactive chromatogram that could actually be used to confirm the presence of your metabolite along with the MS data. And we allow creation of methods with multiple survey scans, so therefore taking really advantage of the 5500 Q-Traps, improve scan speed and performance, as well as supporting some of the workflows associated with GSH reactive metabolite. So for processing the analog data, we support two workflows. The conventional one with a PDA in line with the mass spec, where the PDA is in line with the mass spec acquisition. But we also support the ability to do offline data collection and merging the information to confirm the presence of metabolites, such as in the case of mass spec alone, radiochromatogram alone. The LightSight processing application will coalesce this information and present you this information with respect to confirmation of metabolite if they're found in both in these types of workflow. The other one that I want to talk about is something that we've been working on for quite a while, and we're about to release some kits with respect to that. It's with respect to induction assays, but looking at it from a CYP inhibition, looking at the protein levels of the CYP 450 and using mass spec as detection. So for those of you all know that CYP inhibition studies are cytochrome P450 enzymes are mainly expressed in livers, and they're responsible for the oxidation and metabolism of the drugs. There's a few family of those proteins available. There's about 70 of those that exist. There's also quite a few variants and subfamilies and isoforms. And they're obviously important in drug development, because they do change the expression of specific changes in expression of specific isoforms to provide information with respect to toxicity. Some of the conventional ways of looking at it, if you're not looking at it from a small molecule, looking at cocktails, inhibition cocktails, would be to look at the enzymes themselves, either by mRNA techniques, enzymatic activities, or Western blotting techniques. It is possible also to look at them. Well, all of these techniques actually offer challenges with respect to either time or sensitivity or selectivity. So we're taking advantage of some of the technology that's been used in proteomic analysis. We have a CYP inhibition study, so CYP, cytochrome P450 protein assay workflow that will allow you to monitor specific synthetic heavy peptides that would be supplied into a kit, and you would actually generate incubation of your microsome fraction, trypsinate them, mix the heavy peptides that would be supplied as part of the kit, and do one DLC 20-minute run and monitor the heavy and the light isoforms to determine a relative concentration to a control sample that's been taking place, that's been analyzed in the same way and processed in the same way. So this is the type of analysis that we do. It's iTrack-based type of labeling on those heavy peptides, and you can see that we can separate all of these isoforms and monitor specific fragments using a Q-Trap system, and it can be done on a 3200 Q-Trap, and the data that we're obtaining are very comparable to what would be observed by RNA assay or even enzyme activity assays. So highly sensitive. We monitor 12 different peptides, 4 unique P450 protein isoforms that we are offering and covering at this point. We're even detecting the very low abundant one, the 2B6, and we definitely have good sensitivity and good dynamic range. We support S9 or microsomal subcellular fraction that can be used, and it does have excellent agreement with other techniques that exist, but could have challenges and longer analysis time. And that's all I had to say.